Now we're beginning with the book, and the workbook will follow closely along with the book that you have by McCall, Physics of the Body. So use this as a guide as you're reading through the book to just sort of help you keep order with the different topics that you see in that book. So first we have Newton's laws of motion. You know, Isaac Newton, he came up with the laws of motion, and they really changed the way that we think about motion. In fact, prior to Isaac Newton, Aristotle, the Aristotelian way of thinking about motion was that objects tend to have a natural state. And when Aristotle looked around the world, he saw that most objects were at rest. And so that natural state was at rest. And then Isaac Newton came along. Actually, Aristotle even thought that this was not just a physical thing, but that this state was almost like a spiritual state. In fact, when Aristotle talks about things moving through the air, moving in motion, that he talks about it like as if it's some spiritual violent upheaval for these objects to say, for example, shoot an arrow through the air, that it was removing it violently from its state of rest. And so Isaac Newton comes along and he has a very different view of how things move, but also just a different view for approaching the physical world. And so his laws of motion are very important. Just as an aside, Isaac Newton did not only come up with the laws of motion, he contributed to science in many different ways, but probably one of his most important contributions to our current world is the invention or discovery of calculus. And so calculus has impacted people in many different ways. All of our engineering and science fields are have a foundation of calculus at the very core. So Newton's first law of motion is called the law of inertia. And inertia, you need to know its definition. Inertia is a measure of an object's mass. So when you find the mass of an object, you're actually finding how much inertia does it have. Inertia describes an object's tendency to stay in its current state of motion. You might not be satisfied by this definition of inertia, and in fact, you really shouldn't be satisfied. Fact is that inertia is, in some ways, a mysterious quantity. Like we know how to describe it, and we know, mathematically to predict how it will impact the motion of an object, but largely our understanding stops there. So I hope that you walk away with understanding the definition, but also embracing some of the mystery in that. Mass is a measure of inertia, as I said. So if I have more mass, it will be more difficult to move an object. I'll say that it's harder to move.